Altair is a declarative Python charting library that makes it easy to build clear, interactive visualizations with minimal code. Its intuitive syntax lets data scientists and analysts focus on what they want to show, rather than how to draw it, making it especially useful for quick exploration and storytelling. We've got Visual Studio Code open, and the first thing we want to do to get started with Altair is set up a Python virtual environment. Now, you don't have to use a virtual environment, but it's definitely good practice, so that's what I'm going with. I'm calling mine .vn, but of course, feel free to name yours whatever you like. Once that's set up, let's go ahead and activate it. I'm doing that from the scripts folder. And there we go. The virtual environment is now active. Next, let's install Altair in this environment. I'm using pip for that, so pip install Altair, and now the package is being installed. At this point, we need a graphical environment so we can actually display Altair charts. If you're using something like Jupyter Notebook, you should be all set. But since I'm working inside Visual Studio Code, I need a different solution. So I'm going with Streamlit. Just to be clear, you don't have to use Streamlit, but you do need some kind of graphical environment that supports Altair charts. Jupyter is a common choice, but for this tutorial, I'm sticking with Streamlit. And it's now installed. A lot of people like to use Altair together with pandas. So for many of you, installing pandas might be a good idea. In my case, I'm not going to use pandas directly in this tutorial, so I won't be installing it. But just keep in mind, Altair and pandas work really well together, so it's something to consider. All right, let's open up our Python file and dive in. First things first, to use Altair, we need to import it. So we'll import Altair as ALT. Now, Altair works with lists of dictionaries. So let's start with a really simple dictionary. This one will have two keys, day and price. Let's say the day is 1 and the price is 53. You can think of this as tracking the price of some product over time. The price might change a little bit every day, and we want to visualize that over time. So now that we've got our first data point, let's add another one. Just like before, it's going to follow the same structure. A dictionary with the same two keys, day and price. Like I mentioned earlier, these individual data points aren't quite enough on their own. Altair works with lists, so we need to define a list that includes both of our data points. Basically, we're just putting data point 1 and data point 2 into a single list. Now we can go ahead and define our Altair chart. We're going to use the chart method from Altair. This method takes a few parameters, and the first one, and probably the most important one, is the data parameter. We define that using alt.data, and this constructor expects a values argument. That values argument is where we pass in our list of dictionaries. So in our case, the value is simply going to be our data list. Once we've got the chart object set up, we can move on to actually building the chart from it. To create the chart itself, we've got a few options. Let's start with markline. That's going to give us a line chart. After that, we'll need the encode method. Now, the encode method takes a few parameters, and here's where we define our x-axis and y-axis. Both x and y need to be set to strings, and these strings are the keys from our data. So for example, if we set x to day, we're telling Altair that each data point should have a key called day, and that'll be used as the x value for that point. Same idea for the y-axis. If we set y to price, we're expecting each data point to have a key named price, and that's what will be used for the y value. But just giving Altair the keys isn't enough. We also need to tell it what type of data each of these is. That's important for how it interprets and visualizes them. Since both day and price are numbers, they're considered quantitative values. That's why we need to use column Q. Q stands for quantitative, and it tells Altair that these values are numerical, basically quantities. Now, to actually display the chart in our graphical environment, which in my case is Streamlit, I'm just going to write chart. If you're using Jupyter Notebook instead, you can do the same thing. Just write chart and it'll work the same way. All right, let's go ahead and test our program. To do that, we need to launch our graphical environment. Like I mentioned earlier, I'm using Streamlit. So to start it up, we run Streamlit, run, and then the name of our Python script. Looks like I've got a little typo here. Chart needs to start with a capital C. Let's fix that real quick. And there we go. We've got our first Altair graph. Now this graph is pretty humble. It only has 2 data points, but we can already see it working. The first data point is on day 1 with a value of 53. The second one is on day 2 and its value is 55. We can hover over each of the points to see their values. Also, if you click on the 3 dots in the corner of the chart, you can export it as an image. And again, hovering over any point gives us the exact values. Like here, this one is day 1 with a value of 53. Let's say we want to add another data point. That's super straightforward. We'll just define a third data point, and of course we'll stick to the same format using the same keys in our dictionary. This time I'll change the day from 2 to 3, and let's keep the price at 55. Once that's done, we just add this new data point to our array. Now, if I refresh the page, we can see the graph update automatically. We've now got 3 data points showing up in the chart. And just like before, you can hover over any of them to see their values. Now, at the moment, we only have a line connecting these data points. But sometimes we might want to tweak the style a bit. Maybe we want to include visible points, little blobs or dots, so we don't just have a line, but we can also clearly see where each data point is. To do that, we just set the point parameter inside markLine to true. Once we refresh the page, we'll still see the line connecting everything, but now we also get a nice clear dot for each individual data point. Let's take a look at another example, and this time we'll work with a few more data points. Instead of defining a full dictionary for each one right away, we're just going to start with the values. Just a simple list of prices. Let's say these prices represent the daily cost of something, maybe bread or whatever product we're tracking. These are just the price values for each day, and we want to chart them to show how the price changes over time. Now, as we've mentioned before, Altair works with lists of dictionaries. So first, we'll initialize an empty list. Then we'll loop over our daily price values, and for each one, we'll grab both the index and the price itself. We can use enumerate for that. It gives us both the index and the value. Then for each entry, we'll add a dictionary to our list. Each dictionary will have 2 keys, one for the day, which is the index, and one for the price, which is the actual value for that day. Once we're done looping through the list, we end up with a brand new list, a list of dictionaries. And now, if we refresh the page, we'll see the updated chart showing the price for each day. By the way, we don't have to use a for loop to build that list. You totally can if you want to, but there's also a shorter way. We can use list comprehension. It's just a more compact way to write the same logic in Python. So we'll create our list using list comprehension based on both the index and the price of each element in the original list, the daily prices. Just like before, we go through the list of prices, and for each one, we create a dictionary with a key for the day and a key for the price. Then, if we refresh the page again, we'll get exactly the same result, the same chart with the same data points. The only difference is that this time, we built the list using list comprehension instead of a for loop. By the way, this framework isn't limited to line charts. It supports other types as well. For example, we can easily switch from a line chart to a bar chart. All we have to do is use markBar instead of markLine. And just like that, the same data is now displayed as a bar chart instead of a line chart. Now, when we're using markBar, we don't really need the point parameter. It doesn't make much of a difference here, since the bars already clearly represent each data point. So just to keep things clean and simple, I'll go ahead and remove that parameter. In the same way, we can also create a circle chart. This one's kind of like a line chart, but instead of seeing lines connecting the points, we only see the data points themselves. So let's try that. We'll use mark circle. And once we refresh the page, we can now see just the individual data points without any lines in between. Now here's something cool. We can actually show more than one chart at the same time. So let's give the current chart a name. I'll call it chart circle, since it's the one with the circle markers for our data points. If we display chart circle right now, we'll see exactly what we just described, circles marking each point. Now let me copy that circle chart and define another chart alongside it. This time, it'll be a bar chart. So like we did before, we'll use markBar. I can go ahead and display the bar chart on its own, and yup, that works just like we expect. But here's where it gets interesting. What if we want to show both charts at the same time? We can totally do that by creating a composite chart. To layer both charts on top of each other, we'll use Alt.Layer. That's what allows us to combine them visually in the same space. Now that we've got our composite chart, let's display it. And check this out. We've got both the bars and the circles showing up together. It's a little tricky to spot the circles at first since they're small and sitting on top of the bars, but they're definitely there. To make things a bit clearer, let's swap out the bars for lines. So instead of a bar chart, we'll use chart line. And now it's much easier to see. We've got the lines connecting the data points and the circles clearly marking each one. By the way, there's actually a shorthand for layering charts. So instead of explicitly using layer, we can just use the plus operator. Now, it might look like we're adding two charts together, and obviously we're not doing math here. These aren't numbers. But using the plus sign is just a shortcut to layer the charts on top of each other. It works exactly the same as using layer, but it's a cleaner, shorter way to write it. So we get the same result, just with less code. Now, speaking of code, you might have noticed something else. We're repeating ourselves quite a bit. If you take a closer look, you'll see that the code for the bar chart and the line chart is almost identical. And that's because both charts are showing the same data, using the exact same data source. We're using the same data list for both. So that raises a good question. Is there a better way to handle this? Is there a way we can write the shared parts just once and reuse them for both charts? And it turns out there is a better way. What we need to do is remove mark bar from where we had it earlier, since that part is specific to the type of chart we're building. So I'll take that out. Now I'm going to call this shared setup just chart, because this part is common to both of the charts we're about to create. We only need to define it once. Then we can reuse this chart object for both versions. So here's how we'll do it. Chart.markBar for the bar chart and chart.markLine for the line chart. This works just like before, and we get the exact same result. Both charts layered on top of each other, showing the same data. The difference is that now our code is much cleaner with no repetition. By the way, you might have noticed that our axes already have names. The x-axis is labeled day, and the y-axis is labeled price. That's because those are the names of the keys in our dictionaries. We've got a key called day, which we're using for the x values, and another key called price, which we're using for the y values. But here's the thing, we're not stuck with those names. Just because those are the key names doesn't mean we have to use them as axis titles. That's just the default behavior. We can absolutely change the titles of both axes to anything we like. Now, just setting the key name isn't enough if we want to change the axis labels. What we need to do is use the alt.x method. And with alt.x, we can still specify the key, but we also get the option to pass in a title parameter. That's where we set the custom label for the axis. So for example, I'll go with days from start for the x-axis. And we'll do something very similar for the y-axis. But this time, of course, we'll use alt.y instead of alt.x. Along with the key for the y-axis, we'll also pass in a custom title. Let's call it price for the day. Now, if we refresh the page, we'll see the same chart, but now with updated custom axis titles for both the x and the y-axes. Let's take a look at another example. This time, we'll see how we can work with dates. So I'm going to bring in some data that represents sales over time. Once again, we're working with a list of dictionaries. Each dictionary will have two keys, one for the date and one for the number of sales. This information shows how many sales were recorded throughout the month, along with the corresponding dates. As before, we'll set up our chart using alt.chart. The data will be our sales data, and we'll go with a line chart for this one. Then, just like before, we'll define our axes using the encode method. X will use the date key, and Y will use the sales key. Now here's something important to point out. For the date, we're going to use type T. T stands for time, and it tells Altair that this axis should be treated as dates or timestamps. On the other hand, the sales data is numerical, so we'll use type Q, which stands for quantitative. Now if we refresh the page, we should see our chart. And notice how the strings we used for the dates were automatically recognized as actual dates. So now we can clearly see the number of sales for each of the months in our dataset. We can hover over the different points, and the tooltip pops up showing us the date each point represents, along with the number of sales for that specific date. Now let's switch things up and work with a different kind of data. This time, we've got a list of employees. Each employee is associated with a company, and in this example, we've got 3 different companies. Just a reminder, all this data is completely made up. It's just to demonstrate how we can visualize this type of information. We also have the salary for each employee. So let's say we want to visualize that. We want to show the salary for each individual employee. For this chart, the x-axis will use the name key. Now notice that the data type for name is N. N stands for nominal. We use the nominal type when we're working with categories, values from a fixed set that aren't numbers. So in this case, employee names fall under that. Then for the y-axis, we'll use the salary key since we're showing the salaries, and that's quantitative data. The values for the data will, of course, come from our employees list. And once we refresh the page, we'll see the salary for each employee displayed on the chart. We can hover over the data points and see the exact salary for each individual. But I think for this kind of chart, it might make more sense to use circles instead of a line. So let's swap out the line for a circle. Now we get a clean circle for each data point. I feel like in this case, circles are just a slightly better visual fit. Now, what if we want to sort the data? Right now, as you can see, there's no particular order. The employees are just displayed as they appear in the list. But it might be easier to read the chart if the salaries were sorted. Just like when we wanted to add a title to an axis, simply passing the key as a string won't be enough here either. So we're going to use Alt.X to get the extra control we need. Now, along with the string that represents the key we want to use, we're also going to add the sort parameter. Since we want to sort by the y-axis, we'll pass in the value y. What that does is tell Altair to sort the elements based on what we're showing on the y-axis. And in this case, that's the salary. So the employees will be ordered by their salary values. If we go ahead and refresh the page, we'll see the exact same employees with the exact same salary data. But this time, they're sorted. The chart now displays them from the employee with the lowest salary to the one with the highest. And what if we want to sort them the other way around? That's actually super easy. All we have to do is replace y with minus y, and that'll flip the order. Now, the employees are still sorted by the value on the y-axis, which in our case is salary, but this time we're starting with the employee who has the highest salary and going all the way down to the one with the lowest. Now, we do have company information for each employee, but we're not using it yet. Right now, we can see who the employees are and what their salaries are, but we don't have any visual indication of which company each one works for. Let's change that by incorporating this extra layer of information into the chart. What we'll do is use color to represent the company. So each employee will be color-coded based on the company they work for. So now we're adding another parameter to encode, and that's the color parameter. And what key do we want to use to determine the color? That would be the company, of course. So we'll use the company key for color coding. And since company names aren't numbers, they're not quantitative, we'll use the N data type, which stands for nominal. And there it is. We've got a legend showing which color corresponds to which company, and the employees are now color-coded. So now, in addition to seeing each person's salary, we can also instantly tell which company they work for. Now here's another cool feature. We can make it so that only employees from a specific company are shown. To do that, we first define the options, which in our case are the different company names. We'll use something called a binding select, and for that, we need to pass a parameter called options. That's where we list out the companies. We'll also provide another parameter called name. Once we've got our options in place, we can define a selection. We'll use a function called selection single. This function takes a parameter called fields, and that's where we set up the options using bind. Bind will be equal to the options we just defined. Now that we've got our selection set up, we can apply it to the chart. First, we'll chain a call to add selection and pass in the selection element we just defined. Then we'll chain another call, this time to transform filter, and again, we'll pass in that same selection element. If we refresh the page now, we'll see a drop-down appear. It's labeled Category because that's the name we gave it. When we click on it, we see all the company options we specified. And now, when we choose one of those companies, the chart updates to only show the employees that belong to that specific company. All right, let's go ahead and remove the dropdown for now. And let's say we want to display the company for each employee instead of their salary. So we'll use the company as the value for the y-axis. And since company is a category, we're using data type N, nominal. Now we can see which company each employee works for. They're sorted in descending order. So we see employees from the last company alphabetically first, then the next one, and so on. But if we flip the order from decreasing to increasing, we now get the opposite. Employees from the first company alphabetically come first, followed by the second, and then the third. Another interesting thing we can do is show how many employees each company has. So this time, on the x-axis, I want to display the companies themselves. We're no longer focusing on individual employees. Instead, we want to show data about each company as a whole. And the specific piece of information we're interested in is how many entries in our list belong to each company. In other words, how many employees are associated with each one. Altair has a built-in function for this, and it's called count. What it does is count the number of entries for each unique value in the column we specify, which in this case is the company name on the x-axis. So now for each company, it's going to count how many employees there are. That gives us a clear view of the number of employees per company. And just like before, we can adjust the sort order. If we change Y to -Y, we'll get the companies listed in decreasing order based on how many employees they have. So the company with the most employees will appear first, followed by the others in descending order. All right, let's move on to another example. This time, we'll work with a mini database of flowers. For each flower, we've got its name and a few properties, things like petal count, height, and fragrance level. Let's go ahead and update our data function so it works with the flowers list instead of the employees list. I'm also switching the chart type from circle to line. And as you probably remember, if we want to see the individual data points on the chart, we just need to turn on the point option. Now let's say I want to explore the relationship between the number of petals, the petal count, and some other property of the flower. So for the x-axis, I'm going to use the key for average petal count. Since that's a numeric value, the data type is going to be Q for quantitative. Let's also give the x-axis a clear title. We'll call it petal count. And what I want to plot against that is the height of the plant. This should give us some insight into whether there's any kind of correlation between petal count and height. So for the y-axis, I'm using the key for average height in centimeters. Again, it's a number, so the data type will be Q. And we'll add a title for the y-axis too, something like height in centimeters. Finally, to make the chart easier to read, let's color code the flowers based on their name. That way, each flower gets its own unique color, and it'll be super easy to tell them apart on the chart. Now, if we refresh the page, we'll see our updated chart. On the x-axis, we've got petal count. On the y-axis, we've got flower height, and every flower is represented, each with its own color, making it easy to follow the data at a glance. Now, since this chart shows the relationship between petal count and flower height, it might make sense to rename the variable for this chart. It won't affect how the program works at all, but it'll make things easier to understand when we look back at the code. Next, I'm going to duplicate this chart's code because I want to create a second, very similar chart. But this time, instead of looking at the connection between petal count and height, I want to look at the connection between petal count and fragrance level. So now we've got petal count versus fragrance. The x-axis stays the same, still using petal count, but the y-axis changes. This time, we'll use the fragrance level key for the y-axis. If we display this new chart and refresh the page, we'll see a visualization of fragrance versus petal count. Now, what if we want to see both charts at the same time? Right now, we can only view one or the other, but in many cases, it's helpful to see both charts together. That way, we can better compare the relationships between different flower attributes. The good news is that this is really easy to do. We just take the first chart, then use the vertical line operator to combine it with the second chart. When we refresh the page, we'll see both charts displayed side by side. But what if Like in my case, your page layout is a bit narrow, and you'd rather have the charts stacked one on top of the other? That's easy too. We just replace the vertical line operator with the ampersand operator. And now the charts are shown one beneath the other, which might make things a lot easier to read depending on your layout.